In recent weeks, the researcher known here as Avi Loeb published and commented on updates that shift the tone of the investigation into Atlas. The two most concrete pieces of information he highlights are 1. A radio detection of hydroxyl OH absorption by MeerKAT, and 2. Recent images that reveal a complex network of jets after perihelion. Both arrive while the community presses for high-resolution data, some of which remain apparently withheld. Researcher Avi Loeb has brought forward new data that shifts the direction of the investigation into Atlas. The most significant update is the first radio detection of the object, achieved by the MeerKAT radio telescope in South Africa. The observations revealed absorption signals linked to hydroxyl OH molecules, a chemical marker typically associated with ice breakup or surface sublimation. According to Avi Loeb, the findings confirm that Atlas is thermally active, releasing material as it interacts with radiation from the mother star of our solar system. Meanwhile, new images show a complex network of jets emerging after perihelion, reinforcing the view that the object remains dynamically active and may be undergoing structural changes in real time. In optical images from the 8th of November 2025, stacked exposures show a luminous halo extending to roughly 500,000 kilometers and at least 7 distinct jets. Avi Loeb points out that these structures could be pockets of ice on a conventional comet nucleus or clusters of thrusters, if the object is a technological artifact. He repeats the same admonition: keep the technological hypothesis on the table while we gather more data. Operationally, he also notes that on the 16th of March 2026, Atlas is expected to pass about 53 million kilometers from Jupiter, and that the Juno spacecraft could use its dipole antenna to search for radio signals at low frequencies from 50 Hz to 40 MHz. That could be a unique chance to detect emissions not easily seen from Earth. The MeerKAT telescope measurements provide important physical evidence. Avi Loeb highlights two fundamental technical aspects. The detected signals appear as absorption, not emission, which indicates the presence of cold gas positioned between the object and a warmer radiation source in the background. This suggests there is gaseous material that is colder relative to the energy source behind it. The width of the signals corresponds exactly to what we would expect if the object's surface were at a specific temperature, consistent with the distance Atlas maintained from the Sun at that moment of observation. Loeb also analyzed the velocity. Considering Atlas's total speed relative to Earth and the angle between its motion and the telescope's observation direction, the data perfectly explains the observed shift in the signals. In simple terms, the detected absorption is real and consistent with molecules being released at predictable temperatures for an object at that distance from the Sun, but this alone does not answer the central question. Are we observing a natural comet or something with artificial propulsion? The stacked images from November 8 were assembled from 24 green filter frames, 35 seconds each, plus a few red and blue frames. The result is a large, persistent halo and at least 7 jets, several of which are starward. Observers cited by Avi Loeb report that the frames were taken under difficult conditions: bright moonlight, twilight, which strengthens the case that the features are real because they persist despite adverse observing conditions. There are two main physical interpretations, and Avi Loeb insists both must be considered. Natural explanation: jets from localized ice patches on a comet-like nucleus, each emitting gas and dust when heated. This can produce anti-tails and jets with various orientations. Technological explanation: jets consistent with attitude control thrusters or propulsion, intentional jetting that could indicate a spacecraft. He does not claim one over the other. He insists on transparency and access to higher resolution images to test these hypotheses with better data. A recurring theme in Avi Loeb's remarks is frustration. The best close-up frames taken by the HiRISE camera aboard the Mars Reconnaissance Orbiter on October 23, 2025 exist, but have not been publicly released. According to Avi Loeb, those images could offer roughly 30 km pixel resolution, a major improvement over ground-based and even Hubble images. He criticizes the institutional response. Formal scientific requests and even letters from representatives apparently haven't produced the same speed of response as public-facing replies to high-profile figures, creating a sense of double standard. Avi Loeb stresses that these data are time-sensitive and could shape coordinated observations in the following weeks. Withholding them impedes the rapid scientific work that the situation demands. One of the most intriguing points raised by Avi Loeb is the incompatibility between the object's observed acceleration and the absence of a corresponding debris cloud. Interferometric observations show a significant deviation from the predicted trajectory, requiring non-gravitational acceleration terms in orbital models. If this acceleration were caused only by gas release, the laws of momentum conservation would require enormous mass loss around 1/6 of the object's total mass. This would mean the ejection of billions of tons of material, which should produce a bright and easily detectable cloud visible to dozens of observatories around the world. However, this massive debris cloud has not been clearly observed. This leaves only two possibilities. There exists an unknown natural mechanism that produces acceleration without the expected mass loss, or some form of propulsion that generates thrust without ejecting enormous amounts of material. Avi Loeb calls for targeted observations in the coming weeks to verify whether the acceleration increases, decreases, or changes direction as solar heating varies, which could provide crucial clues about the true nature of this mysterious object. Avi Loeb has actively advocated using existing assets like Juno to monitor Atlas and radio when the object passes near Jupiter, March 2026. The practical idea is to use Juno's dipole antenna to scan low frequencies, 50 Hz, 40 MHz, for any transmissions. He also urged radio networks to keep monitoring Atlas because its incoming direction lies within 9 degrees of the 1,977 signal. The MeerKAT O detection proves there is molecular material to study with radio telescopes. The next step is checking for coherent emissions that might indicate artificial activity. Avi Loeb is careful. He offers no proof of technology, only a call for coordinated, continuous observation and criticism of the institutional slowness in releasing crucial data. To wrap up this video, here's a summary of the latest updates. Confirmed 08 radio detection specific frequency lines detected in late October with well-measured Doppler shifts. The first confirmed radio detection of the object. Complex jet network mapped recent images reveal at least 7 jets and a halo of approximately 500,000 kilometers, including star-directed jets that are unusual for comets. Non-gravitational acceleration measured orbital models confirm acceleration terms. No measurable acceleration detected outside the orbital plane. Mass loss questions to explain acceleration through outgassing. Atlas would need to lose approximately 1/6 of its mass, around 15% or roughly 5 billion tons, but no corresponding massive cloud has been observed. Unique photometric behavior, rapid brightening, and a blue shift near perihelion differing from standard comet behavior. Pending high-resolution data, high-resolution images taken in early October still await release. Their availability is critical for analysis. Notable origin trajectory. Atlas arrived from within 9 degrees of the famous WOW signal direction from 1977. Juno observation opportunity predicted passage at approximately 53 million kilometers from Jupiter in early 2026, offering potential for additional monitoring. Coordinated global monitoring. Over 200 observatories are tracking Atlas, with hundreds more expected as it emerges from conjunction. We have new and measurable observational signals: OH radio detection, jet network, non-gravitational acceleration, and at the same time, there are critical data gaps: withheld high-rise images, need for coordinated radio surveillance. If mass loss is confirmed at the scale the calculations require, Atlas will be an extraordinarily active comet. If this cloud doesn't appear, we'll be left with the uncomfortable question: what force caused the acceleration without the corresponding mass?